Alright, time for parsing number 2. So where did we leave off? So I guess we just finished off the explanation of alternative. And so what's in my learning plan here? Oh yeah, so we're now talking about how to put together like a set of parsers, basically. So, you know, it's I can't imagine we can do much with parsing a singular character. What we really need to do is parse a list of characters, and so that's where kind of combinators, I suppose, come into play. And so, you know, and this option, you could say, still applies to a singular character. I mean, or a singular unit of thinking. I don't know. But it also could apply to parsers which match multiple characters, or multiple characters in a row, I should say. Yeah, it's very general, and the more helpful ones to think about are sum and many. And I believe actually Parsec doesn't have. It's not called sum, but it's many one. Where is it? I hate this on Chrome. Many one. What the? Oh. Okay, so I guess it's defined in here. And right. Oh, right. What am I saying? So yeah, I guess you know what? Then that makes me wonder what the heck the point of sum, or sorry, of many one is. But so they're very similar what the two do, and they are just simply about matching multiples of some function, or some parsing expression. And so many matches 0 or more, and so many it can actually throw us into a bit of well, many will always succeed is basically the point. So if I said many car of semicolon, this will succeed no matter what. I could have anything here and it will succeed no matter what, because it can match on 0 cases. And so it is a neat way, if you do want to encode the fact that it's acceptable for it to not exist. You know, there might be some cases where 0 or more is exactly what you want, but oftentimes, usually what you want is sum. So, I suppose I import control.applicative. And so this is failing because it did not find even 1. And so this would, now this succeeds because I have at least 1 there. Makes sense. This is what the documentation is saying. But this will also succeed if I put in a random number of times that this exists. It will match all of them. So it's going to continually match on each character until it gets to a character that it does not match on, and that's when it's going to terminate and give us back our result. And, you know, of course, now this doesn't just apply to, you know, singular characters. I could have some string of hey, And so this would work on, for example, if I did hey Lois, this is going to return me a list of what I matched on. And that's because if we look at the type of many or some, for that matter, it's saying some alternative f. So f in this case is going to be ParsecT. And I'm just going to get rid of the sum there because it doesn't really mean anything to us. And now I can delete that. And so this what I gave as an argument to sum was a string of hey. If we look at the type of string, it takes a string as an argument and then returns that string matched. And so it's very simple. It's not going to do anything complicated or kind of thinking of its own. It will just return exactly what you looked for if it does exist. And so that for that reason, that means that we are matching on a ParsecT string, or we are giving ParsecT string as our input to sum, and so it's going to return us a list of that A. And so again, it's this is where we're really starting to see, I guess, monads in action, because like the ParsecT is always just going to be wrapping whatever value it is. So it's almost more like I'm kind of at the point where in my head I'm implicitly doing this. I'm saying like, oh, like okay, I have a parser which takes an A, or this sort of abstract A. A parsing A, and is going to give me back a list of that thing. And that's kind of how I mentally process it. Just because, really, at the end of the day, monads don't really do... they help us do control flow, but they don't help change what the value is. And the control flow that ParsecT is doing here is just simply... providing a monadic interface, and providing us the state of the string that we are giving it. And so, yeah. So, I don't know, I'm so tired today. But what's another one I should Oh yeah, string choice. So choice is one we saw, and let's actually go and implement choice. If I look at choice in Parsec, choice is really, it's actually kind of simple, and just for the sake of actually getting some code written, we're going to say that choice, so choice is going to take a list of parsec tsuma, and it's going to return us, or it's going to build us a parsing expression of that kind. And so this could be, for example, we could feed to choice car semicolon car A car B, and this will match on a semicolon, an A, or a B, and will consume one character just because of, well, the fact that it's consuming a character, or each of these consume one character. So it's going to run one of these and consume a character, because that's how any of the internal functions work. And so if we have, we uncons P of parsers, then what we're going to want to do here is say P alternative or option, you could say P choice P's. So try this option And then if it does not work, try the next option. And so really, we're going to try the semicolon first, and then we're going to try the character A, and then the character B. Yeah. So, yeah. And we will try, and we're going to also put another example here. And if we say, because this would also have to work. Hey, string, hey, and then string hello. And the reason I put this one here is because these kind of overlap. So if this is going to succeed, then we will not run this. But if this was able to succeed, then we would not get to it because we've already would have consumed up to this part here, and all that would be left is the y. But we're not looking for y, we're looking for hey with two y's. And so just to finish this off here, choice at the end of the list. What is our identity case? Our identity case is going to be empty, because, Parsec, because Parsec is an alternative. So we have the empty method that would be established for ParsecT. If we look at ParsecT, we can see that it has an instance of alternative where empty gives us a ParsecT. And so this is going to say, if there was only a singular choice, this would read as P or empty, which is really the same thing. I'm going to use like a ton of equalities here just because to show you that I'm doing pseudocode. The result of this would be the same as P. And so P is either going to, so let's say P fails, is going to then try to do empty, and empty is automatically going to fail because empty is by definition a failure. And in the case of maybe our failure case or our empty case is nothing. I believe there's even, this is not an alternative, but alternative is very cool, and you can use it for a number of different things. But there's very few cases where I find I actually need it for outside of parsing. Yeah. So now if we tried choice, we said that our P is choice of car, semicolon, car, A. Now this is going to succeed on A. You can see that it's expecting A or a semicolon. Going to work, not going to work. And now if we change it to string, hey. So this could not work because one returns a string and one returns a car. I could change this to say string of this, and then that would work. And so I can either have that or I can have hey. Both would work. But if I had, that would work. What am I saying? Yeah, that would not work because we're going to start from reading the first index, and we're not going to see hey. We're going to see an R, which obstructs our hey. And so we're an unhappy horse. And then now that's choice. And so many till and many till underscore. Just go back to Google. Maybe they changed that. Oh yeah, I think they actually took out many-till. Did they? What? Okay, I guess they took out many-till. I don't know why they would do that, because there's actually a very useful function. But let me pause this for a second. Actually, I didn't actually look. I paused it for a split second and then I went, never mind. Because I guess you could implement many-till or do the same effect as many-till in another way. So maybe that's why they got rid of the function. But what many-till is well, let's demo it. Many-till, so P is going to be many-till, and so what does many-till take? Many-till takes a parsing expression and an end parsing expression. So I am going to say that I'm going to try and match on, I want to match on a string like this, for instance, where let's say I'm matching for ease. I want to go all the way up until the semicolon. And so I'm going to say that P is equal to many-till char E up until char semicolon. And so this is going to work all the way up until, up until the semicolon. And I believe so if we wanted to make many-till, then I guess let me try something here. If we did that's so weird. You know what? I am going to check this. This is really weird. Okay, I found many-till, and maybe this is where I was using it from. I don't really recall. But many-till, so both of these, what I was a little confused is that this shows that many-till also consumes that like up until character. So it consumes the like this expression here. If I was to cut this out and just, I'm going to copy and paste this here. What am I saying? I need that. This consumes the semicolon, but does not allow me to retrieve it. And so I was a little confused because the case that I had, I actually needed to use that end function, but I needed to go up until that end function. And so this is what I used because, okay. So if I do import control dot applicative dot combinators, suppose I have to go to Cabal and add parser combinators. And so this is a library of functions that can be used with any parsing library in Haskell, pretty much. so I guess in this case, parser 0 is the same thing as empty. Yeah, parser 0 literally equals empty. And that's all there is to really say about that. I can also do parser fail, which is just, would say ran out of options. And so it would fail in the exact same way, except it would give me a message. Yeah. So we talked about that. And the last one there's kind of two more categories of what's important, or three. So set by, just because it's the closest to this, is set by is what we would use to create a CSV parser, or a very simple CSV parser. So let me check this out, because I actually haven't tested this fact yet. Let's say set by some any car, or I could say many any car, because that would allow the cell to be blank. Except that could fail. I think this could fail in a weird way. Let's try this out. Set by car. Whoa. That's so annoying. I'm sure. You know what? The easiest route here is just to do this. So they are the exact same thing. A lot of parsing modules will re-export stuff, and so that's what I'm seeing here, is that I have two of the exact same functions that are coming from different modules, but there's no way to tell that for the compiler. So if I say parse p empty source name a perfect. What happens if I do that? Well, wait, will this just succeed no matter what? Maybe this might just succeed no matter what. Oh, yeah, because it's many of any character. What am I saying here? Okay, so the many is also another case. Many any character is like literally you are kind of setting yourself up for a trap where it could, succeed when it shouldn't, which is arguably the worst kind of failure, when it's false success. And so how can I do this? So a better way to do this might be many none of right. Okay, and that looks like it's working. Although, I mean, the specification of what a CSV is so loose that I don't know if this is for sure working, but I think you get the idea of what set by is doing. And, for example, that also returns properly. I can have a 1 here. I could have a $sign there. there's really, I guess there's no more restrictions on what a CSV is besides like new lines basically. And I could do this by just, by, how could I do this? I would say, well, suppose I would say many, I would take this P and I'm going to say P2 is that text.parsec.many many of P car new line is how I could write a full-on CSV parser. And so can I do this? What if I did? Although, yeah, that will match on that first. I don't know. I probably have to redo the parsing logic there. But anyways, I don't want to make that the main demo anyways. So yeah. Anyways, so try is I would say try is very closely connected to the alternative operator, this one here, in the sense that, like, let's say we had, we went back to our simple p car semicolon. It would not make any difference to say try in this case. Like, we could do it, it would type check, because the type of try is just that it takes a parsec, any parsec expression, and returns an adjusted parsect expression, where it can fail and can recover from that failure. And so it actually wouldn't even matter with car. We could do car, this, and then car A, and this would cause us no problems whatsoever. I'm just going to quit and then call them back into this because that is really annoying me. I'm just going to import text.parsec. Because I really just wanted to show many till, I believe. And so let's say this is our here. I can still use this and it will not fail even if, let's say this is A, and so it has to fail once in order to get to the A. This is going to be completely fine. But if I was to say instead that I want to do string of hey or string of what's up, then this will never work to get what's up, because what's going to happen, and so if I write something that could in theory succeed, this is going to what? Okay. That is weird. I thought that was the whole point of try. Oh, wait a minute. Is it this? Okay, yes. So what happens is Oh, wait a minute. No, this is still invalid as a test. Yeah, okay. So what the difference here is that when we had what's up, it's going to try the first, it's going to try to start the string parser of hey, and it's going to fail before it even gets started. And so we don't need try in this case. But in the case of hello, that is going to confuse the parser because it's going to see H and H, and so it's going to start to parse, and it's going to go into that like sort of defined parsing logic. E and E is also going to succeed, but then when it gets to hello, or sorry, the L, it's going to say Y does not equal L, and it's going to treat it as if it was just running the string function. It does not, the string function does not know that it is wrapped in a list of alternatives. However, we can bypass this by saying try string hey, and so now this will work on hello because it will fail, and then what it will do is it will say, oh crap, I thought this was going to work out, it looked like it was going to succeed, but it didn't, so put what I've consumed back and then restart. And so it's going to consume HE, and then it's going to put HE back, and then it's going to consume hello and finally succeed. And then I guess the last kind of group to talk about is the options. So we have like a couple here, and they all really do the same thing between option, option maybe, and optional. Well, I shouldn't say they do the same thing, but similar premise. And so option, all of these are basically like, the thing that might come next doesn't have to be there. Option will succeed. Well, option will always succeed, and it will default to this A if this parsing expression does not work. So, like for example, let's say I'm parsing. I don't know. I try to parse a character, and that character that in particular that I'm looking for is an A, and so I have a default of A here. And maybe a better example is like if we cannot parse, some options set, then we have a default option set that we are going to use in place of what we could not parse. And that could be because maybe the user never supplied such an option set. Option maybe is just going to, it's basically going to save us from dealing with a parser failure. So instead of failing out of like Parsec as a whole, it's just going to return that failure as a maybe. So for example, if I did P equals option maybe car 1, and then I tried to parse P hello, it's going to give me right nothing. Because that's that nothing is coming from the type of option maybe, which is the maybe A. Nothing being a case of maybe A. And optional, I do not even want to return it. I'm just kind of consuming it, is basically what's going on here. And I'm automatically discarding the result of P. And so I think that's really it for like the different functions to kind of know about with parsing and to understand. And we can chain them together and all of that. And so the best way to kind of talk about the best way to actually show this all is through just a demonstration. Let me look at the time. Okay, we got time. So I'm going to do a demonstration on SemVer. So SemVer, I'll post the actual this link here in the description. But so just going back to regex, there's a regex thing I found down here, and this is absolutely nuts. Like, I have no idea what that means. I'm sure I could figure it out, but I don't see why I would. I could instead do this very clearly through parsing. And so there's two examples that are of, chief importance here, and one of them has metadata, the other does not have metadata. What is it? So it's major, minor, and patch for these first three pieces here. I'm not sure what this beta is. Actually, I'm going to need to pause this for a second. So for that, I just had to clarify a certain rule that I was wondering if you could have the plus come before the minus, and I don't believe you can. I'm not an expert on SemVer, and I don't really honestly care about SemVer. It's just a good example for parsing. And so, yeah. So how do we break this down? So we have to build something that can parse this and any other type of parser. So what is the strategy here? Strategy is, we should break this down and groupify this. So I know that there's always going to be a major, minor, and a patch, and then there's going to be potentially there could be a the rest of this, and then if this exists, then there's the potential for the plus and all of this. And so as I go through, I guess the possibilities of what can exist becomes clear. So, all right, so let's start with the main part. And so main part, the ParsecT. And I'm going to say that this is a so this is really quite simple. I know that it can be, so I mean there's a possibility that this is like, let's say a 10, this could be 100, this could be 1,000. It could be any length of digits. And so, but I know that this has to be a digit. And so, I could say that it has to be, I could use any char, and it would naively match. But it would also match on things that aren't actually what I want. Oh, jeez. I want to do many digit. And so that is going to give me my major. I am going to parse a character of just the dot, which is I know is going to come after major. And also too, so this is how I usually think of parsing is, and sometimes I do need to backtrack, but I usually just kind of go methodically, like how could I, properly pull off piece by piece. That's exactly what we're doing. And so now if I look at minor, it is going to be the same thing. There's going to be many digit. And keep in mind, this is going to be ParsecT list of car. So I have to turn that into an integer, which I will do in a second. And so there's going to be another car here, which is this one here. And so that's going to peel it off and get rid of it. I'm going to do that just to show that I'm clearly throwing it out, because I have nothing. I don't want to return anything about the fact that there was a car there. I only care about what the major, minor, the patch versions are, and what are these called again? These were the pre-release and metadata. I don't even know what that means, but yeah. So now, patch is going to be many digit as well. And so this is my main part here. And so I would say pure major minor patch. But this would be a list of car as opposed to an int. And so I could do one thing actually, and I could just say read here. And the reason that this would work is because I am being very clear to the compiler about what type I do intend to get back, and that's an int, because this is the last statement here. So really, this is kind of like the type signature of my last statement here. So it would infer what the types are, but just for the sake of being clear, I'm going to say let to int equal read, and to int I'm going to type annotate it, so that's a string to int, and then I am going to say to int. And it would type check anyways, but I'm more just doing that so that we can see clearly what is going on. Oh, and I need to state that this has the stream constraint, which is basically talking about the ParsecT monad and how it can yield characters for me to parse, or check/parse, because parsing is just basically checking. Yeah. And so now, what's my entire thing? So I know that I'm going to call this main parser, or full parser. So full parser, I'm going to have, in order, I know I'm going to have the main part, and then I might have, there's the possibility that I have the rest. So how can I do this? Well, I you know what? I'll come back to that because I don't need to think about that right now. How would I parse it if it is there? And I believe that this, yeah. So this metadata, the pre-release can have an arbitrary number of random things, which are either numbers or an integer. And so I'm going to say my next function I'm going to build is the pre-release. So I can either have. What can I have? So I know that I have. Either a multiple characters, or multiple letters, or multiple numbers, and although that's I guess that's technically metadata, but I'm going to assume that for the pre-release part that it does not have a mix of the two. It's either going to be a string of numbers or a string of a successive numbers or successive letters, and so that means. So I'm just kind of thinking out loud here. I either have many, some letter, or I'm going to have some digit. And this is going to be separated by a dot. Yeah. So this should actually work, I believe. I guess I'm pretty quick at thinking through how to do parsing here. This does take a lot of time to think through on your own. But I guess, how did my brain get here? Because this is kind of automatic at this point. I've done so much parsing, but I was thinking about how would I parse a singular step here, and I could either it's either going to be, well, in the simplest case, my simplest thinking of it is that it's going to be either a letter or it's going to be a number. And then I expand that a bit to say that, well, actually, it can also be a list of numbers or a list of letters, and so okay, I know that in that place, like that following, following the dash, that in the place, between a dash and between these dots, there will be that construct of some letters or some digits. And I don't believe it's possible to have something like this where it's just nothing. So we would not want many. And good thing, because many kind of, it can be a source of false failure or false success. And then, and so whatever that construct is of some letters or some digits, we know that they are separated by this dot character or a period. And so I actually don't really need that because I don't have multiple statements. So why the do syntax? So this is also ParsecT, and this is ParsecT sum. This is going to be a list list of car, because some letter matching once would give me a list of car. And because I am using setBy is going to get me a list of that separated by thing. So it's going to give me back a list of A. And my A here is some letter or some digit, which the type of that is a list of car. So I'm going to get a list of car. And And maybe there's a nicer way to do that. Well, there is a better. You know what? And I think it's worth showing here. And we're just gonna do this for the sake of showing what's doable with parsing and kind of what's good parsing here, because there might still we will be returning this in a way that there's still some ambiguity about a given unit, like is this letters or is this digits, and so we could have a data type number or string, and so this is either I'm going to say n string, or stringy is what I'll call it, and it's going to be a string, or it's a number. A number is not reserved or not used, so number is an int. And now this is getting a little hectic. So and except there's one more thing we need to do, and that is turn these digits into a number. And so I am going to say that we also have this function f, where f is of the type string to int, and f equals read. And I believe this should work. I'm just going to say import right, and I just have not changed my type signature. Good sign, because I bet this works if I'm getting a class issue, and it does compile. Wow. Even I'm a little surprised. But so yeah, this is a parser for pre-release, and now we just need to do our last bit, which is the metadata. And so metadata is really looking like the same thing, except for that it can be just a random list of alphanumeric. Yeah, I guess so this is definable by alphanumeric here. This is also fits the mold of alphanumeric, and so I'm naively going to say that alphanumeric would work here. And so metadata stream sm car, I know I'm going to need that, and I'm going to do parsect sum list of string. And so Metadata. How do you work? We are going to, well, let me just pull that down here so that I can see it. And I guess, so this is also going to be set by, but the core thing that we want to find is some alphanumeric. Some alpha num would match on any of these individual pieces. And so we're good there. And so now I can just say sep by and then also separated by the dot. And we are good to go. So now we have we have built up our 3 core pieces. We have our main part, our pre-release, and our metadata. And so now we just need to figure out how do these work together. And so our full thingy, our full parse, will be parsec tsum something. I'm going to say A for now. Full thingy. So how does this work? Because there doesn't need to be anything after the major minor patch. So just filling in the blanks here. I know that I have to do main part. Major minor patch. So I guess I would want to do one way I could do this. So I'm thinking in terms of option. And the complicating part here. So let's pretend there was only. We didn't have to think about metadata for a second. We only had to think about, and metadata is everything after the plus. We're just thinking about this piece here. So I guess what I would do is I would use optional. Was it option or optional? That has a default. Yeah. So I would say option here. I'm not sure what the option would be at this moment, but I would then do pre-release. And so pre-release, what does pre-release return? It would return me a list of number or string. And so my option, if there's no such thing, so I would have to have this default value in the case that there is no pre-release, so I could just have an empty list here to signify that there was none. And this would work. But now, I don't believe it's possible that I could have oh, you know what? Actually, this is metadata. Huh. So, okay. So I'm gonna. Then I guess this is actually quite simple. I just need to do this exact same thing for metadata, and it's just gonna look like this. Metadata also is returning a list of something, so I'm just going to say that we didn't find any if there is no such thing, and then I'm going to run my parser expression of metadata. And it's expression because it takes no arguments and does a parsec action. Yeah, and so this works, and so I could build. So I guess I need to define a type here for my SemVer. Let's call it. Let's make it like this. Major, minor, patch, release, and metadata. And these are all just going to be type synonyms. Type major equals int, type minor equals int, type patch equals int, type release is a list of where am I blanking? Release is a list of number or string, which I will pull back up here. And then there is type metadata, which is, I guess, just a string. And I'm just going to use it here as well, just so it's very clear what I'm doing, but that doesn't really change any behavior. And this would work, so I would just want to then have my full thingy return a SemVer, and I guess I would say SemVer. I want to unpack this, and I can do this. I can pattern match on the extracted variable, and so I'd have major, minor, patch, maj, min, pat, pre-r, meta, and this would work. Now, like, just for the sake of having fun, because I actually do enjoy this. I mean, Haskell is a beautiful language, so it's fun. What if this was... Oh, wait a minute. I lie. I actually messed up on something. And this is true except for the minus and the plus. So what I can do is quite simple. I would just do car. I guess it would be minus pre-release, and that works because that's just going to toss out the character, and then it is going to continue on. Same with this. It's going to toss out the plus character and then get the metadata and return it in this place, which is going to be so the result of this expression here is going to be given to option, which is also parameterized with an empty list. And so if this succeeds in returning metadata, then it will return that metadata. If not, it'll give me back this empty list. Same with pre-release. And now this will work. But, and so I might as well just destroy and then rebuild. Nope, that's not what I want to do. But what about if metadata was only possible when we did pre-release? So there has to be a pre-release in order to have metadata, and so we're implicitly only checking for metadata in the case of pre-release. So we'd have to I guess change this up a bit. So so I know option would change, and I feel like it would be like almost like maybe the easiest way to think about this is pre-release prime, where pre-release prime equals do pre-release prime is going to be do pre-release, and you know, in this sense, in this region of code, we're assuming that we can find pre-release. We don't need to worry about if it fails, because we are wrapping it with logic about how to deal with it failing. And so I guess we would say pre-release, and then we would say car plus, and I guess we would need to return this pre-release as pre-r. And then I guess we would just probably run our option of metadata. Although I would want to, I was thinking of putting that there, but this would mean that in order for me to return pre-release successfully, I would also need to have plus there. Even if I'm not returning plus, I'm saying that plus must come after pre-release in order for pre-release to be valid. Otherwise, it will return a parsing failure. So I'm going to take this, put it in here, so that it can fail, and it won't cause this whole entire do block to fail. So now this gives me my meta, and I guess then I would say pure of pre-r meta. And so I guess, so meta is going to be, so this is only going to even run successfully in the case that there was a pre-release. Like if there's no pre-release, this just fails, and I get back option, which I have to deal with. I'm going to put like this. I guess we know that this no longer exists. Yeah. And so I just have to say what's, like, you know, option is the result of really what's the default of the type that I would return if it does fail. And I'm starting to see what this is, because you know, I'm only running this option statement now in the case that I've already found pre-release, and it's still an option and works the same way, but I've just kind of changed how I preface that that action. And I might not even try to run that action at all, whereas before I will definitely run this option no matter what. And I will definitely run that option after I tried to parse for the pre-release. But now I only try to parse the metadata in the case that I've already found the pre-release. And so that's the difference here. And so I think it's fair to say, and I guess it really is arbitrary too, what type I end up returning. And so here I'm going to return the pre-release and the meta, which also might just be nothing at all, because I have said so in the option. And so if this is the type of pre-release, then if this is how pre-release works, I can deduce that the type of pre-release is ParsecT sum tuple of number or string, and then another list of string. And so I suppose, and what this means is that for option, again, option, this A that I have to give here has to be the same type that would be given by the successful evaluation of this statement. And so my A in this case is a number or string, or a tuple, which has a list of number or string and then a list of string. Meaning that if I want to have just some sort of fail case here, I have a tuple of empty lists, which implicitly this list is of the type number string, and this is of the type list of strings. And so now, just to get back the kind of behavior I had, I'm also just going to unwrap it like this and pattern match on it, and then now I have my new function, which works like so. That's fair. Full thingy prime. What's this saying? Oh. So I guess then all I would need to say, what I mean to say is that it's a list of metadata. And now this is just complaining because, why is this complaining? Oh, because I don't have my stream here. I thought I did, but I do not. And so that's a pretty obvious mistake. There we go. So this works. Let's test it out as the fear creeps into my body. Full thingy. I'm not going to give it a source name. Just so that I can print it. So that this means that it did work, but the terminal tried to print it or run print on the final result of SemVer, and it did not work. So I also need to give a instance of show to this because I am using number or string in my SemVer. And that works. What if we change it up a little bit and we do beta 43? We also get a number 43, and this looks like it's working. What if we change this to being 00 just for the fun of it? I guess that's going to convert it to an int. So what is that? That doesn't really prove anything. Yep, this is working. What if I make this just some massive number? Cool. What? Whoa. What the heck? Oh, I think that's the upper bound of int. So that makes sense. That's so the parsing is working, but I guess that's how read works. Again, read is weird, but yeah. So that's really all there is to say and show about parsing. If you understood that, you should be good to make your own parsers. I will be doing another tutorial on async specifically. So keep tuned for that if you are interested. But otherwise, I sincerely hope you enjoyed. I really, really love the power of parsing in Haskell. And, especially too, if you don't understand it yet, no worries. Like, you probably, I hope you do. Like, that's my goal, to make you understand it as soon as possible. But there's a possibility, a very real possibility, that that's not the case, and you have more to learn. And really, how you learn it is by practice. So, go and try to find some things you can parse. Maybe even try to build your own JSON parser. And it doesn't have to be as great as ASIN, but try and build just some sort of parser for a file format. And I think BNI files, if I remember, are another very simple one. YAML files would be very simple to do. XML is a little complicated. Try parsing an HTML tag. The head of an HTML tag. So, anyways, so again, thank you so much for watching, and please like, share, and subscribe, and hope you enjoyed these videos. Bon voyage!